Algebra 1 Lesson 34, we are looking at our arithmetic sequences and being able to recognize them, extend them, and create formulas for them. So let's look at a couple different vocab terms. First sequence is a list of numbers that follows a rule. And an arithmetic sequence, well, that just has a constant difference between the two terms, meaning we are adding something consistently or subtracting something consistently. So if we look at some of these examples, 1, 3, 5, 7, we would say, yeah, we're adding 2 between all of them, so this is arithmetic. 2, 4, 6, 8, same. 5, 10, 15, 20, we're adding 5 to each of those. 2, 8, 32, 128. Well, it looks like we're multiplying by 4 every time, but that means that we don't have a constant difference. That's actually geometric. We'll get to those in a little bit. Arithmetic sequences have those constant differences, so we're looking at these top 3 are arithmetic. The common difference, we say this is the difference between 2 consecutive terms. So if I did 10 minus 5, that's 5. 15 minus 10 is 5. 20 minus 15 is 5. 25 minus 20 is 5, and so on. If a sequence doesn't have that common difference, it is not arithmetic. In this case, since we're multiplying by the same thing each time, it's geometric. Are these arithmetic? Well, what is the common difference? Okay, in this one it looks like, okay, 25 minus 5, that's 20. 125 minus 25, that's 100, so we have no common difference. 2 to 12 to 22 to 32, we are adding 10 each time, so that's good to go, that's arithmetic. 7, 12, 17, 22, we're adding 5 each time, so that's arithmetic. 10, 100, 1,000, 10,000, well, we're adding a 0, but that means we're actually multiplying by 10, which means we don't have a common difference. This is not arithmetic. And last one, 8, 16, 24, 32, we're adding 8, which is arithmetic. We call each of these terms a certain name, so a sub 1 is our first term, a sub 2 is our second, a sub 3 is our third, and a sub n is our nth term, saying maybe we want the 100th or the 1000th. We call that whatever we want is our nth term, a sub n. We're going to look at a pattern to be able to figure out what is our formula that we can use for these arithmetic sequences. So if I have the first term number is 1, we would say that value is 7, and we just call it a sub 1. Second, our second term, we add 4. These are just, it's a made-up pattern. We're just saying we start with 7 and we add 4 each time. So with our first one, we're saying I am adding 1, 4. So I have my first term plus 1 of our common differences. Third, I take my first term and add 2 4s. So I'm adding 2 differences to my first term. Fourth, we add 3 differences. Fifth, we add 4 differences. And lastly, n, we add n minus 1 differences to our first term. If you notice, when we look between our term number and how many differences we add, it's always 1 less. If we have 3, then we're adding 2 differences. 4, we're adding 3 differences. It's always 1 less. So when we get to our n, that means we need to add n minus 1 differences. Okay, that's what helps us determine what our formula is. So let's try it out. So we have 2 ways of showing our formula. First, we have this one that's called the nth term formula, a sub 1 plus n minus 1 times d. Or this is more of a recursive way to show it, saying that we have our term, our a sub n, our nth term, which would equal the previous term plus our difference. That's more of a recursive way to say it. Okay, we're going to focus on doing it the nth term formula way. So if we look at our a sub 1 equals 6 and d, our difference is 9, we want the first 5 terms, which means when we do that, we're going to take 6, add 9, then add another 9, add another 9, which means these are this is our pattern. This is our sequence. 6, 15, 24, 33, 42. Now, when we go to create our formula, we use both of these terms, and we need both of them. We would say, if our formula is a sub n equals a sub 1 plus n minus 1 differences. Then we need to say a sub n is, well, our a sub 1 we can replace with 6 since that's our first term. And then we're adding n minus 1 of our differences, which in this case is 9. Now, we can't quite leave it like this because this is not in our simplest form. So we need to distribute that 9, get a sub n is equal to 6 plus 9n minus 9, which means we can simplify, add those constants together, and get 9n minus 3. Which means even if I want my 100th term, I can get it. My thousandth, my millionth, I don't have to actually add up to those term numbers. I can plug them into this formula and get it. So when we look at my second one and look at those 5 terms, I would say it was negative 60 plus 4 plus 4 plus 4 plus 4, and we would get these terms. To get our formula, I would just plug it in just like the other one and say a sub n is equal to negative 60, my first term, plus n minus 1 times 4. So when I distribute out, I get a sub n is equal to negative 60 plus 4n minus 4, and combine like terms. So we get a sub n is equal to 4n minus 64. So, just like before, I could plug in any number here and get the value of that term. This is a really important formula to know and to memorize and to make sure that you know how to use it. This is a really good way to remember how to do this. So first, we need a couple things. We find our first term. We find our difference. We plug in the values into our equation. We distribute. We simplify by adding like terms, and then we have our equation. So if you follow all of these steps, you will be just fine finding the nth term formula for an arithmetic sequence. Let's try a few different examples of this. So if we have 18, 25, 32, 39, that means we're adding 9, so our difference is 7, or sorry, we're adding 7, our d is 7. Sorry, yes. Okay. I had a little moment where I was like, maybe I'm saying this wrong. And my a sub 1 is 18. So we can plug it into our formula and say a sub n is equal to 18 plus n minus 1 times 7. Which means when I distribute out, I get 18 plus 7n minus 7. And I combine to get a sub n is equal to 7n plus 11. And that would be my formula. Let's do another one. Our a sub 1 is negative 14. My difference, well, it looks like we are adding 9 each time. So I would say a sub n is equal to negative 14 plus n minus 1 times 9. I would distribute, get negative 14 plus 9n minus 9, and then I combine and say a sub n is 9n minus 23. And that would be my formula for any term that I want. And lastly, our first term is a sub 1 is negative 110. And our difference is, well, it looks like we are adding 25 each time. So I will say, just like we did, a sub n is negative 110 plus n minus 1 times 25. And I would distribute and get a sub n equals negative 110 plus 25 n minus 25. And my final answer would be a sub n is 25n minus 135. That would be my formula. Okay? So taking a sequence, turning it into a formula is a really important skill to have. So we can find any value of the sequence knowing our formula. So let's take this. A sub 1 is 4, d is 6, find our formula, and then figure out what the value of our term 14th, our 14th term would be. So I'm going to plug it in and say a sub n is 4 plus n minus 1 times 6. And when I distribute out, I get 4 plus 6n minus 6, so I have 6n minus 2 as my answer. That is my formula. If I want my 14th term, that means I need to do a sub 14 is 6 times 14 minus 2. So I do 14 times 6, let's see, 24. So we get 84. So a sub 14 is 84 minus 2, which is 82. Let's see if we're right by pulling this rabbit out of the hat. And we are correct. We get 82. Now our next one, let's make our formula. So we do a sub n is negative 4 plus n minus 1 times negative 2. We can have a negative difference as well. It just means that we are going down in values. So my a sub n is negative 4 plus negative 2n plus 2. So my a sub n is negative 2n minus 2. So when I want my 12th term, a sub 12, we would do negative 2 times 12 minus 2, which means my a sub 12 is negative 24 minus 2, negative 26. Should be my value if I did this correctly. And let's check it, and we get a negative 26. Perfect. All right, last example. Finding the common difference will help us determine what comes next. Here it looks like we're adding by 4, so we should get, let's see, we should get 19, 23, 27, 31. Okay, if we are going from negative 4 to negative 6, negative 8, it looks like we are subtracting 2 each time, so we should get negative 10, negative 12, negative 14, and negative 6. And lastly, if we're going 15 to 7 to negative 1, well, it looks like we're taking away 8 each time, so we should get negative 9, negative 17, negative 25, and negative 33. Okay, so make sure that you know how to recognize an arithmetic sequence, be able to create a formula, and continue a sequence for a little while. Well, I hope this helps with your homework and for studying.